This is my first TED Talk. I watched a few videos to see what's involved in TED Talks, and it was a heavy call. I have to solve world hunger and then world peace doing these TED Talks, so I'll try my best. So I have notes to help me through. So I just wanted to change it a little bit, I suppose, or build on what I showed this morning, and wanted to frame it around optimizing dietary forage inclusion rate. So we might try and make it a little interactive. Be nice to hear back from the audience. So what's the limit we can go with forage in our diets? So maybe a show of hands. Are we thinking for high producing dairy cows, are we around 55% forage? A couple of hands up there. Let's go to 60. Anyone think that's the limit? 65? Couple of hands. And then 70? Couple more, and then above 70. Anyone brave enough? No. Okay. Very good. Very interesting. So I was looking in the literature to see how high can we go. And some great work from Larry Chase and Rick Grant in upstate New York. They surveyed a number of New York dairy herds, and they found herds doing 75% forage, corn silage, alfalfa, and grass silages, with rolling herd averages of 48 kilos of milk. So really impressive performance from really high forage diets. That was kind of observational. I was looking at a number of herds across the state. There was some work from the USDA. I'll butcher their names now, but Schuler and Kelcher. And they did a control experiment. They increased forage inclusion from 42% up to 66%. And they found that by moving up in forage proportion, they are able to hold energy-corrected milk at 40 kilos per cow and increase feed efficiency. So the cows essentially ate less when they were on those higher forage diets, but converted more of the nutrients or were more efficient on that higher forage diet. Looking at in the nutritional simulations and formulations, what we're talking about there, we're looking at forage NDFs as a percent of body weight over 0.9. So that can be a bit scary when we get up there. And total NDF intakes as a percent of body weight of over 1.2. So high levels. When we look at the maximum a cow can do, so how high can a cow actually go as a proportion of her body weight? There's work from grazing studies looking at the forage NDF, and we've measured over 1.8% of body weight in total NDF intake. So our cows can do it. Granted, in the grazing systems, we do lose some animal performance, but cows are capable of eating lots of NDF. So we'll go interactive again. Why might we be interested in these high forage diets? Does anyone want to shout out a few advantages of those high forage diets? Cheaper feed, yeah. So Jonathan's on the money there. So that was my second point. So the first one I down as it's the power of the ruminant. So we're evolving into a world where we're growing in terms of population. There's bigger demands for highly nutritional animal source products, which is great. And our cows, for me, they're superheroes. They can take human and edible feed and convert it into really highly nutritious food that our best athletes want to eat. So that was my first one. The second one is with Jonathan. We can reduce purchase feed costs. So we can have quite drastic impacts on purchase feed costs. And if we do it right and we can hold animal performance, we can really improve income over feed costs. And Mary Laure showed earlier income over feed costs, looking at 10 to 15% greater profitability. Any other advantages people want to shout out? Over here, yeah. So that's a nice one too, yeah. So maybe less evidence of health, but documentations of it out there. Better animal health, better rumen health, and less involuntary culling. So interesting observations from the field there. And yeah, I'd agree. We'd see the work from Dave Barbano and the Minor Institute on the higher de novo fatty acids and driving milk fat, which is great too, especially if we're getting paid for kilos of fat. So anyone else? We'll keep moving. So maybe a couple more I put down, and maybe they're bigger picture. It can help us with our farm self-sufficiency. So when shocks come into the market, like geopolitical disruptions, we're protected against those to a degree. We're less at the vulnerability of commodity markets. whole farm nutrient balances. It's something we need to consider too, both our nitrogen balances per hectare and our phosphorus. And it's something our friends in the Northern Ireland especially are encountering right at the moment from a regulatory point of view. That extra purchase feed coming in can bring phosphorus with it and increase those phosphorus balances, which can translate to poor environmental outcomes. And the final one then was covered on the animal health. So just it's a very rosy picture I'm painting. These high-forage diets are great and it's very positive. So what's the catch, or what are the considerations? So do you want to help me here again? Anyone's concerns or considerations we need to watch out for in these high-forage diets? Hugh's up the back, not enough forage. Yeah, so that is the tricky one. Not enough forage, so we will need more forage acres. If we're talking of going up 10 to 15, 20% more forage in the diet, those acres need to come with it. And those acres need to have the growth potential. So we need to monitor that, make sure soil fertility is good, and fertilization programs are on point. There was another one shouted out that I missed. Forage quality. Yeah, so that's a really big one. So forage quality, it needs to be extremely high. So what we are demonstrating there this morning, and it needs to be consistent. We need enough of it, like Hugh mentioned, but we need consistency in that high forage quality. When we're in high forage diets, they're making up a large proportion of the diet. So if we see a blip in quality, we'll pick it up in the tank, and then our benefit of those increased income over feed cost is lost. Rick Grant, again, I mentioned Rick a lot. He was very good, is a very good scientist. He demonstrated these high quality forages do have that faster rumen